If you ever want another problem like one of these, just let me know. So the first two problems are asking you to determine the number of solutions and whether they're real or imaginary. So there are always two solutions to a quadratic. But there's kind of, the kind of three possibilities here. One is that there's two real, two imaginary, or there's one real that's repeated.
Yeah.
So sometimes that's called one. I don't know. It's like depends on the system. It could be one, or you count them both, so it's two. If it crosses the x-axis, which it does here, there are two real in this situation.
Yeah.
That's when it crosses the x-axis. So that's what you're using to answer that. There are always two solutions unless you consider a repeated root one solution. You may want to ask that. I don't want to tell you wrong on what your instructor wants.
No, yeah. I think that's good.
So that's it. That's it for that. Now this one on the right, this one does not cross the x-axis. So there are still two solutions. They're just both imaginary. Oh, I see. Your instructor wants you to choose. Okay, I get it. You're supposed to write two and then imaginary or two.
Oh, yeah,
real.
yeah.
I get what they want. I would not do well in this test. I would. Okay. And that's because it does not cross the x-axis, right? This horizontal axis, that's it.
Yeah.
Okay, we'll look at number 5. Okay, so main thing with a square is to solve a square problem, use square root. And you're going to take a square root of both sides of the equation. Now, on one side, you have to write plus or minus. And it's usually the side that does not have the variable. So it's key to not forget that. There are two solutions. The square root of 64 is 8. So the answers are positive 8 and negative 8.
Yeah.
It becomes more critical for number 6 to do this part correctly, because after you take the square root on the left side, you then have to, do a few more calculations, a few more steps, if you will.
Mm-hmm.
So square root on the left side here, y plus 2 squared equals plus or minus the square root of 16. It does undo the square, so it's y plus 2. There's no reason to keep the parentheses because there's nothing else going on. But it's very important to write plus or minus 4, and then maybe even better to write two equations, y plus 2 equals 4, y plus 2 equals minus 4, like that. And then you got to solve them both. You could solve them simultaneously, subtracting 2 from both sides. So you get y equals 2, y equals negative 6.
Yeah.
Any questions on those?
No, I think I pretty much get those ones a lot.
Fantastic. All right. We're gonna do 9 first on the next row. The reason we're doing 9 first is because the first and most common type of factoring that you do is the greatest common factor. You'll see this on standardized tests also. So m squared plus 4m equals 0. There's an m in both, so you factor that out. And if it's not clear how you get what's inside parentheses, you're dividing each of these by what is on the outside. And that's why it becomes m plus 4. Now, very important here is to set each term with a variable, has to have a variable, equal to 0. So you're going to set that m equal to 0 and then m plus 4 equal to 0. You'll see that in the next couple of examples. It's a little more important there. But then you solve. So you subtract 4 from both sides. M equals -4. M equals 0. And this goes back to that first two questions we were asked. This is two real solutions. Like you're not going to be asked that, but that's what is meant by two real solutions, is two numbers.
Yeah. Okay.
All right. And is that okay? Any questions on that? All good?
Yeah, I think we're all good.
Okay. All right, so number 7 is written like this. My personal preference, I really prefer the 0 to be on the right, and it is perfectly okay, acceptable to do that. Okay, so this is after GCF, one of the next types of factoring is what's called a equals 1. That's referring to the 1 in front of the x squared. Couple of different types of this you could see here, but this is you're looking at the last number and then this middle number, and you're finding two numbers that multiply to 4, +4, but they have to add to -4.
Yeah.
And what I suggest is writing 4 and writing out all the possibilities, like 1 and 4, 2 and 2. But notice none of these add. 1 + 4 doesn't add to a negative number, and neither does 2 + 2. That's because they have to both be negative to get to add up to a negative number.
Right.
And you choose the one that works. You probably had a whole unit on factoring at some point, maybe in a previous course. So this becomes x -2, x -2. And you set them each equal to 0. So you set both of them equal to 0. It is redundant, but that's the behavior. You just do it, and
Yeah.
it will help you in another problem where maybe it doesn't work out as nicely as this one did. So you add 2 to both sides, add 2 to both sides. So your answer is x equals 2, x equals 2. So this is an example of that repeated root. Like graphically, this thing looks like this. Yeah, I could just make this as nice as I can. It touches. This is the repeated root.
Yeah.
And so is that one real solution? Is it two? I mean, I actually don't know what the right legalistic definition is. I mean, I think it's still two, but they're just repeated. So keep that in mind. Number 8, go to number 8 next.
Okay.
So they're giving you 3 different types of problems here. This one's got the issue where the right side is not 0. So you make it 0, and you don't just change it to 0, but you move the number to make it 0 on the right. You really want a 0 on the right hand side.
Yeah.
Okay, so now this problem, you're trying to find two numbers that multiply to -6, but they have to add to +1. +1.
Yeah.
Okay, so the way to do this is to start just with like 1 and -6, or -1 and +6, and then just say, okay, what about 2 and -3, or -2 and 3? Which of those add up to +1?
It would be -2 and 3.
-2 and 3, yes. It becomes x -2, x + 3. And you set those each equal to 0.
So that'd be x equals 2 and x equals -3.
Yeah. All right, so that is it. I mean, those are your answers. That's the two real solutions. Okay, so I'm gonna move to 15, 16, and 17 now. If there's no questions on that.
Oh yeah, because 11, 12, and 13 are kind of the same.
Oh, I'm sorry. I totally missed that. I just went right by that. No, we
Oh
should
no,
do
you're
this.
fine. I mean, yeah, we can do those too. They're kind of
They're kind of the same. I should have,
similar.
yeah, let's do 13 first. 13's most like 9. Maybe you can tell I've been, doing a lot of lessons lately, so a little more mistakes than
yeah.
usual. This has a greatest common factor.
Yeah.
It also has two terms. That's one of those things to look for with a greatest common factor. It's not like a guarantee. Like when you're playing sports, your coach probably says, well, look for this, look for that. Sometimes you see it, sometimes you don't. That's the case here. All right, so the x gets factored out, x minus 13.
Yeah.
Right, so you set that equal to 0. So it's x equals 0 and x equals 13 for your final answers.
Yeah.
Okay, so let's look at, I don't know, we'll do them both. Let's look at, 11's probably better to do next. Grab 11. Do you get a calculator on your final, do you know?
Yes, we do.
Okay, so you could, for example, graph this if that was more convenient. I think this is pretty reasonable to factor, but you could, go and graph it and see where it hits the x-axis. But -18, it's like 1 and -18, -1 and 18, 2 and -9, -2 and 9, 3 and -6, -3, and +6. Do any of these add up to +7?
It would be 9 and -2.
Yes. So that becomes x plus 9, x minus 2.
Yes.
All right, so that gives you two answers here, -9 and +2.
Yeah.
Okay, so the 12 is a different type of factoring we haven't talked about. It's called difference of squares.
Okay.
It has a specific form. You notice there's two terms again,
Yeah.
but only one of them has a variable in it. So if I go back to the greatest common factor problem, it has two terms, but they both have a variable.
Right.
Okay. So x minus 4, x plus 4 is the answer. Now I want to show you where that comes from. So when it's in this form, a squared minus b squared, it always becomes a minus b times a plus b. So when you look at x squared minus 16, what you figure out is what do you square in each case. So the x, when you square it, goes back to x squared, but you got to figure out what number goes here, what variable or letter, and it's 4. And that tells you your a and your b. And then you're just putting those values into the formula on the right here.
Wait, say that again?
I'm going to give you some more examples. Just maybe give me a moment here. Maybe that was really fast. No, not very good. Let's try
Oh,
again.
no, you're good. I was just
Um,
catching up a little.
All right, so let's try another problem here. Let's say it's x squared minus 25.
Mhm.
So what you're trying to figure out is what squared minus what squared gets you back to the previous line. Okay,
Oh, yeah, go ahead.
and it's x there because when you square the x, obviously it goes back to becoming x squared. But what number goes here such that when you square it, you get to 25?
5.
5. Okay. So now it's like, well, what's the formula? I'm going to write it below here. A squared minus b squared becomes a minus b, a plus b. In your problem, a is x and b is 5. And what you do is you use those values, use x for a and b for 5 here. X minus 5, x plus 5.
Right.
Okay, so do you want to let's have you try one more here. Keep that up. See if you, let's say it's like x squared minus 100.
So it would be x minus 10 and then x plus 10.
Yes, that's perfect. All right, so let's move on to another part of the review here, 15, 16, and 17. We're now talking about complex numbers. And the whole thing here is that, like, normally for a long time you've been told you can't take the square root of a negative number, but you really can. It's the square root of -1 times 25. And then you can break those apart, the square root of -1 times the square root of 25.
Yeah. So wouldn't these be the ones where it's like, so for this one to be like 5i?
Exactly. Yeah, you have to look at them separately. That's 5 and that's I. It's 5i.
And don't you have to put plus or minus before every single one of them? Or is it?
No, not here. I mean, there are situations where where that is the case. So but these are less complicated than that. So let's look at 16. I think 16 is the square root of -81.
Yeah. So that would be 9i, right?
It would be 9i, yeah. The last one is the square root of -32. It's a little bit different. It's like I'm trying to figure out here because your instructor is not really emphasizing reducing roots, but this one does not work out perfectly. Like the other ones were 9i and 5i, they worked out really nice. This one you have to build a factor tree. It's kind of different than the others. It's so before you get to that, it's the square root of -1 times the square root of 32. So we already know there's an I, and you just have to you just have to break this apart. So 2 and 16, 2 and 8, 2 and 4, and 2 and 2. And for each pair, you bring a 2 out in this case.
Right.
So like, I'm gonna use the space on the right here. So on the outside is 2 times 2. You have that I square root of whatever is left over, which is 2. So this becomes 4i square root 2 when you're all done.
Yeah.
Okay, let's
So
do, oh, go ahead.
these ones I always get confused on, like, because of the whole tree, like you have to break it down and then I get
Yeah,
confused what to bring.
this would be a good idea is to ask your instructor, I mean, are you gonna have to reduce a root like this, or are they all gonna be perfect roots like this one? Because we could review how to do this if
Yeah.
that was,
I'll
it's like,
star this one and ask him tomorrow.
yeah, or maybe get another example in class. Like, could you give me another one like 17? He should
Yeah.
know that, okay, that's not a perfect one. Like, here's the square root of negative 80i, and you work on that in class. And if we have more time at the end, we can definitely come back and do that.
Yeah.
Okay, so let's look at 22 next. We'll come back to the other ones, but so this is like 3 separate problems that we just did where you have to reduce each of these individually. So you already told me that's 5i. You already told me that's 9i. This middle one is 3i. And then you just combine them. You just add them as if they were x's or any other variable. So that's 5i minus 3i is 2i plus 9i is 11i, like that.
Yeah.
Okay, so let's go back to 18. So the only reason the parentheses are needed is when there's like something on the outside and you're looking for a number, which is not the problem number, or like a minus sign, which this one doesn't have, but the parentheses are only needed when there's something holding it there. And in this case, there's nothing holding it. Absolutely nothing. So you're just combining like terms.
Yeah.
So you combine these numbers here, 3 and 5, you combine the 2i and the 7i, 8 plus 9i. Now, very important is usually they want your answer in a plus bi form,
Right.
meaning the constant before the one with the I.
Yeah, I remember this. I remember like you
And
telling me
it's
that.
like, it's really, it's like, why does that matter? It just, that's the way they want it. So go with that. All right, so let's look at number 20. So this problem has, there's a reason to have the parentheses on the right here because there's something holding them there, this minus. But on the left, there's nothing holding it there. There's nothing, no number being multiplied in, no minus sign. So you do not need those parentheses. On the right, you do need to distribute in here. You do need to change the signs for each of those. -4 minus 3i, like that. And then again, you just combine like terms.
Right.
2 plus 2i. Any questions on that before we move to 24?
No, I think I'm good.
Okay, let's do 24. All right. So here you're going to distribute in this 5i. You're going to multiply it times both of these. So the intermediate step here is 5i times -4 plus 5i times 2i. I times I is I squared. And we'll get to what I squared is, but it is -1. But that's kind of off to the side here. So 5i times -4 is -20i plus 10i squared. it's a good idea not to try to like deal with the addition and the I squared being -1, just kind of work it in steps. Rather than trying to figure it out. If it was a multiple choice test, a lot of the wrong answers would be ones that you might actually think to get if you don't handle the signs correctly with this. So while this is the right answer, it's in the wrong order. The -10 has to come first, and then the -20i.
Yeah. And the good thing about my final is he's letting us have a half sheet of like notes that we can use during it.
Great.
So yeah.
So I'll start boxing in some things that may be worth putting on there.
Yeah, that'll really help.
So one of the suggestions I tell students is to start actually with a bigger sheet than they need, and then right day before, or with the test, condense it if you need, or rewrite it nicely. But because some of the things you'll just be like, oh yeah, I already know that, I don't need to write that down. Start with something a little bigger is one idea. So the only things today that we've come across that might be worth, this difference of squares might be worth putting down, since you haven't seen that in a while. What else? Maybe these examples, I don't know, they might be the kind of thing that by the time you get to the test, you're like, oh, I know that, I don't need to write that down. But
Right.
that's up to you. But I'll try to be more aware of that as we go through this.
Yeah.
In case I see some things that could help. I was actually reading something on Twitter. There's a college professor who gives open notes, open computer on his final, and he actually said that the score didn't change very much for most students because they either knew it or they didn't. There wasn't like enough you could do.
Yeah.
But don't I mean, you should still take notes and have a note sheet, but I was really compelled to find out more about it. I was going to actually ask the guy about his research, because I would think it would surely help, but
Yeah.
there's a lot of other things that go on with that. Okay, this is a FOIL problem. So you're going to take that 2 times the 3, which is 6, 2 times the I, that's 2i, minus I times 3 minus 3i. Actually, I did this out of order. No, I'm sorry, that's right. And then I minus I times minus I squared, like that. And again, it's just you can really make a mistake here. Minus I squared becomes minus a minus 1, which is +1. 6 plus 2i minus 3i. So the 1 and 6 makes 7 minus I, or minus 1i.
Yeah. Okay.
All right, so we'll keep going here. Twenty-eight. So x squared plus 16 equals minus 28. I mentioned that if you really want to get 0 on one side of the equation, so x squared plus 16 plus 28 equals 0. I'd like you to try factoring this. Find two numbers that multiply to 28 but add up to 16.
Okay.
I know I'm putting it on the spot. I think you can do it. It's
Yeah, it would be 14 and 2.
exactly. Yeah. Okay, so what do we need from here? What's the next step to solve this? Get the values of x.
So then you set both of them to 0.
Yes.
So then it'd be x equals -14 and then x equals -2.
Yes. Perfect. Okay, moving along to 29.
Yes.
This will actually account for something that we were going to do earlier. Excuse me. So you want to solve for x. You really want to isolate the x squared. When there's only one variable in one place, you just isolate it. So you're going to do that by multiplying both sides by 3. And that gives you x squared equals minus 45. So now this is bad. I know I said always move it over to the left. That's only true for some of the problems. Of course, this is the exception. This is a lot like problem 5 and 6. Do you remember what we did in problems 5 and 6?
Yes, we just took the square root of the.
Exactly. Yeah, you take the square root of both sides. When you take the square root, though, it's plus or minus. You were kind of asking me about that earlier. You're like, hey, is it plus or minus? It is when you take the square root. It's not when it's already square rooted.
Okay.
So we were looking at problems like the square root of negative 81. Yeah, like there is no plus or minus.
Right.
But if it were x squared equals minus 81, then it would be plus or minus the square root of minus 81.
Mm-hmm.
So the difference is when you take the square root, you're supposed to do this step. Okay. We get another chance to reduce one of these roots here. Square root of -1, square root of 45. 45 is not a perfect square. Okay. So you have to break it apart. You start with prime numbers. You always start with 2. 2 doesn't work here. It's not even, but 3 does. 3 and 15. And then you try it again. You're like, all right, well, 3 worked. Maybe it'll work again. It does. 3 and 5. You stop when you get prime numbers on the leaves, this kind of inverted tree.
Yeah.
So with the pair, you bring one out. The minus square root of -1 becomes the I. You bring the 3 out. Square root of what's left over is 5. You bring the plus or minus down. A lot there. Plus or minus 3i square root 5 is the answer.
Yeah.
Would you like another problem like this? Or
Yeah,
continue?
probably.
Okay. Okay. So it started out with this operation to like manipulate this so that it was x squared. It may not be exactly that. Do you remember if your exams were pretty close to the reviews with just changed numbers, or were they?
Yeah, they were pretty similar.
Okay, so let's do one. Let's do 1/4 x squared equals minus 20. Right, so what is the first thing to do here? We want to isolate the x squared.
So you would multiply 4 by both sides.
Yes. So that becomes x squared equals -80. And if, from here, how do you get x alone? It's kind of alone, but it's got this square here. You've got to get rid of that. How do you undo a square?
You square root it.
Yeah, so square root of x squared equals plus or minus square root of -80. This is the kind of thing that's really important to put on your sheet, your note sheet. Somehow like remind yourself that it's plus or minus. That's a common thing that gets forgotten by students. So x equals plus or minus the square root of -80. So it's plus or minus the square root of -1 times the square root of 80. So you break 80 apart. You start with 2 and you see how far you get. 2 times 40. You try 2 again. 2 times 20. Hey, it keeps working. 2 and 10, and then 2 and 5. So for each pair, you bring one out. The reason it's pairs, by the way, is because it's a square root. If it were a cube root, we would be looking for triplets. That's just kind of an aside, but it's that is the reason for this. So you've got plus or minus, you've got an I, you've got 1, 2, you've got another 2, square root of what's left over, 5, and then you just combine, kind of reorder. Generally, you put the number before the letter, before the root.
Yeah. Okay, that makes more sense.
Okay, so we're up to 37 now.
Yes.
When we talked about this many weeks, month ago, I don't remember. I made some reference to like what the actual graph looks like. The top one is a circle. You'll either see that the next half of this course or in a future course. It's good to know that just because it helps you to figure out, well, how many solutions are there? The second one is a line. So the line could miss the circle. It could go through the circle and hit twice, or it could hit it in one spot. So the point here is you could have 0 solutions, 1 solutions, or 2 solutions. And believe it or not, on standardized test prep classes or tests, standardized tests like the SAT and ACT, they actually even ask questions like, how many solutions does this have? And you may just have to answer something simple like this. Now, the only way to solve this is through substitution. Well, the only reasonable way, we'll say.
Yeah.
Which means it should be solved for something already. The second equation is already solved for y. That's going to go in wherever you see a y. So you have x squared plus parentheses 5 minus x squared equals 25. You just put that, whatever it is, in for y. Don't try to simplify it yet. That'll come in the next steps here. So very important. This may be another thing to put on your notes, is that 5 minus x squared is 5 minus x times 5 minus x. It is not 5 squared minus x squared. You have to write it as a binomial times a binomial.
Yeah.
Okay, so when we FOIL this, we get 25. 5 times minus x is minus 5x. Minus x times 5 is minus 5x. Minus x times x is plus x squared equals 25. Okay. Combine like terms, maybe. So you got x squared and x squared, that's 2x squared. Minus 5x is minus 10x plus 25 equals 25. Generally, you want the right side to equal 0. So to do that here, we're going to subtract both sides by 25. That's 2x squared minus 10x equals 0. This is two terms. Do you remember what we did to solve when there's 2 terms from an earlier problem?
You take the 2 out in front.
Okay. Can you take anything else out? Do they both have a variable in them?
The 2x.
Yeah, 2x. So it becomes 2x. And then you're dividing both of these by 2x. So that becomes x minus 5 inside. Excuse me. What do you do from here? Do you recall?
And then you factor.
So we've done that. This is the factored step here.
Oh yeah.
So go back to, if you need to, like a problem like 9 or 13.
Oh, do you set both equal to 0?
Yes.
So 2x equals 0, yeah.
Okay, could you solve each of these for me?
Yeah, so the first one would be x equals 0.
Good. And
And
right.
then it would be x equals 5.
Fantastic. Okay, so the nice thing here is now if you go back to your picture, I know you don't need this for this problem, but it confirms what maybe you thought was most likely, which is that it hits the circle in two places. But
Yeah,
that's only half the answer. It's only half the answer. So what I'm saying, reason I'm saying that is, yeah, X is 0, but you need the Y value. You need to know the Y value that corresponds to when X is 0. And you get that by putting 0 in for X. So
right.
Y equals 5 minus 0, which means that Y equals 5. These are ordered pairs as your answer. When X is 0, Y is 5. And then similarly, when X is 5, it goes in there. Y is 5 minus 5 or 0. So that's another ordered pair, 5 comma 0. It's just in this problem that they happen to be flips of each other, or switches. Switch is probably the right word.
Yeah,
Definitely would recommend reworking this one on your own. Either pausing the video and seeing if there's steps that you miss. Just to go through the steps, just to be like, all right, I can do this. And I can make some up like this if you want, but that's the key here. The key is to be able to replicate it on your own.
yeah.
All right, 39. How's volleyball going? Are you in season right now?
So we had school season and then that ended in like early November.
Okay.
And I've been doing like club volleyball since I was maybe 11 or something like that. And this was my first year not doing club. So I,
Have you found that you have a lot more free time now, or are you just
oh my
replacing it with
gosh,
something else?
so much free time.
Okay. All right.
Yeah,
Yeah.
crazy.
Well, that's good. That's good that you give yourself a break. Maybe you jump back in. Maybe you find another activity.
Yeah, I've been like going to the gym a lot, and then I think I'm also gonna get a job.
Great.
So
Those are both excellent. Okay. So we're going to graph each inequality. If you ignore the less than or equal to, and it just said, hey, to graph y equals x squared plus 3, there's many ways to do this. It really helps to know what the transformations are for this. And there's only one, but you said you had a calculator. So if you were really stuck, you could actually graph this in your calculator, but maybe you can tell me what does the plus 3 do?
it, um, oh shoot, I always get it mixed up if it's up 3 or if it's right 3.
So this one is up 3. You could get that in your calculator. You do need to know the parent function, what it looks like. The x squared looks like this. So the up 3 obviously moves it up 3
Right,
like
okay.
that. I would double check that because it means it's really not a hard problem if you got a calculator. Plus, you probably aren't doing this, but you actually could get the calculator to do this for you. So in terms of where you shade, do you remember how to determine where you shade, whether it's inside the parabola or outside the parabola?
I remember doing it, I just do not remember how to determine.
Okay, so there's two options. One is to look at the direction of the inequality if it's solved for y. The second is to test points or test a point. Do you remember, does either of those sound familiar? Like to test a point?
Oh, yes.
So what you're trying to decide is, like, when you test that point, when you put 0 in for x and 0 in for y, and you need to pick something that's not on the line. The reason is you're trying to determine whether the point is true or false. On the line will always be true. You're looking for either it's right or it's wrong. So what you're trying to figure out is this a true statement? Is 0 less than or equal to 0 squared plus 3? Is 0 less than or equal to 3? Is that true?
Yes.
Yes. So you shade the true side. So that would be everything like that.
Okay. So if it's true, you shade on the outside of the.
You
parabola.
shade whichever side contains the point.
Okay.
There's a lot to this, but I'm trying to not overly develop this. Like if you try to point up here, it would not work, so you would not shade that. And
Okay.
maybe part of the problem is it appears like there's more than two regions. There's really only two regions, 1 and 2 in this problem, inside or outside. Yes, no, maybe.
Wait, sorry, say that again. That was like,
There's only two. There's only two. So like here, let me give you something else. There's two regions. There's inside the box and outside the box. If you have a line, there's two regions. There's over here on the right, over here on the left. If the line, even if the line curves, there's still only two regions, one above and one below. So for quadratic, whether it opens up or it opens down, there's still only two regions. There's inside, or outside, inside or outside.
yeah.
Because these lines go up forever. So
Right.
you can never like cross into the other region.
Okay.
All right, so really quickly, running out of time here for the last one. The way you would graph this one is to determine the intercepts. So you would factor. I'm just going to factor that real quick for you. And that tells you that there's a -3 and a +1 intercepts. So you graph those two. You're supposed to get the vertex too, which we really don't have time for. 1 -4. Okay, so it looks like this. You can always put this on your calculator. This time though, it's a dashed line. And the reason it's dashed is because of this inequality here. So I need to change this. It's something like that. And then again, there's two regions. You're either shading inside or outside. You'll find that you end up having to shade inside this one if you test a point. So I'm sorry this last one was rushed. I assume we'll probably meet again, but this is how you'd work through this. We could probably spend some more time on this next time if needed.
No, yeah, I think everything was good. We didn't really need to go through it.
Okay. If I don't see you, hope you have a great holiday, and I'll definitely be available next year to help. So, but if you do need some help before then, I do have some times through next Tuesday available.
Okay, thank you so much.
You're welcome. Great to help you. Have a great night. Bye now.
Bye.